Hello, welcome to the session Applying the Principles of AWS Well-Architected Security Pillar. I'm Garvit Singh, a solutions developer based out of Virginia. Before I begin my session, let me tell you a short story. This story will also give you a better idea as to what to expect from rest of the session. So I was working with a customer about a couple of years back and his web application was under a DDoS attack. His web application had multiple CloudFront distributions and load balancers, and it took us a bit of time and effort to identify the attack and then take actions to implement infrastructure protection to ensure any such attack in the future does not impact his web application. Two things to note from this story: the time it took us to identify the attack, and then the steps taken to implement infrastructure protection. And these are the areas which we are going to focus in this session: detection and infrastructure protection. Our agenda: we'll take a quick look at the well-architected framework, specifically the security pillar of the framework. We'll see two solutions in action, and these solutions will show you how you can scale your security. We'll talk about some of the key features, design decisions that went into these solutions. We'll see each of these solutions in action through a demo. And then I would like to conclude this session with few action items for you. The well-architected framework is essentially 5 pillars: operational excellence, security, reliability, performance efficiency, and cost optimization. Each of these pillars have few design principles, and they give you a step-by-step guidance as to how your workload should be orchestrated. In this session, we are going to focus on the security pillar and more specifically the design principles of detection and infrastructure protection. If you want to dive deeper into the security pillar, I would highly recommend checking out the session by Ben Potter on security best practices. So what do we mean when we say detection? When we say detection, we mean to identify potential security misconfiguration, potential security threats in your accounts, ensuring highest security standards across your entire organization, which can also help you achieve compliance obligations, and automating these detection and remediation techniques to help you scale your security. Similarly, when we say infrastructure protection, what we really mean is protecting your network, resources, and applications at layers 3 to 7. We want to implement a consistent security posture across your entire organization, and then we want to automate these infrastructure protection techniques to help you scale your security. You would have noticed that I repeated the phrase implementing security at scale because that is really one of the key takeaways from this session. So let's take a look at our first solution, which addresses the design principle of detection. This solution is built around the service AWS Security Hub. AWS Security Hub takes its security findings from various different AWS services like AWS Config, Amazon Macie, Amazon IAM, and some of the findings might look like, let's say AWS Config have a finding that S3 buckets in your account do not have access logging enabled. Or let's say Amazon IAM might report in your account that security credentials have not been rotated for 90 days. So these are some of the common security findings. And these services feed these findings into AWS Security Hub. AWS Security Hub integrates with CloudWatch Events rule, which in turn implements the remediation actions using either Lambda, Systems Manager automation document, or step functions. So essentially what Security Hub gives us is a centralized detection and management of security alerts, and it helps you to automate compliance checks and remediations. Now let's see the solution in action. All the solutions come with a pretty detailed landing page, architectural diagram, and implementation guide. And we can launch the solution from the web page itself. So let's launch it. We'll give it a name. And we'll create the stack. For the purpose of demo, I already created it, so I'll cancel this one. And we can see the stack was deployed. One of the key resources that gets deployed as part of the solution is a service catalog product. So let's take a look at that. And you can see the service catalog product, its details, the deployable artifact, and we can launch the product. The service catalog product is essentially a collection of playbooks or remediation action, and these remediation action addresses 14 of the security findings from the CIS security benchmark. CIS is Center for Internet Security, and the solution currently addresses 14 security findings from this benchmark. Now let's launch the product. Let's give it a name. And you can see the remediation actions or the playbooks listed here, all 14 of them. They are currently disabled, and I'll keep them disabled for the purpose of demo because I want to show you how the remediation works. But if you enable these remediations, next time if there is a security finding in your account, that finding will be automatically remediated for you by the solution. Now we'll launch this product. Again, I already have it launched, so I'll cancel this one. And we can see it was created successfully. Now let's take a look at the Security Hub console. So this is the AWS Security Hub console. You can see a summary of your security score, and you can see the findings being reported in the account. So let's take a look at the findings. And these are the findings currently being reported in your account. One particular finding that we are interested in is a finding around IAM password policy, which requires that users have at least one uppercase character in their password. Pretty common security best practice. And you can see the finding here being reported in the account. You can see all the details of that finding. And if I scroll down, you can also see the remediation. So let's take a look at the recommended remediation. And the recommended remediation is essentially telling you to go to the console and set up the password policy, which enforces users to have at least one uppercase character. You can see currently the IAM password policy is minimal, and that is why the security finding was being reported in the account. Now we are going to fix this finding using one of the playbooks from the solution. And you can see the playbook has the same code as the finding. So we'll trigger this playbook. And it uses CloudWatch events rule to invoke Lambda function to resolve this finding. The workflow should be resolved by now. And we can see the same finding being resolved. It takes a bit of time for the status to get updated, but if I see the notes, you can see the password policy was updated. And if I go back to the IAM console and refresh it, we can see the password policy being updated. So what we saw was there was one CIS security finding in your account, and we remediated that finding using a playbook from the solution. We we did it manually, but if you enable automatic remediation, next time there is a finding in your account, it will be automatically remediated for you by the solution. It's important you think of scaling. And when you think of scaling to hundreds and thousands of accounts, you would quickly realize the importance of such automated detection and remediation techniques. I showed you the solution working in one account, but the solution also supports member accounts of your organization. When you have organization with hundreds of accounts, implementing consistent set of security guardrails becomes mission critical. And the solution can help you achieve that with fairly minimal effort. We also saw how Security Hub can provide you a single pan view, giving you visibility into security posture across your organization. So we saw the solution in action. Now let's talk about the architecture, and it should be easier to relate with the architecture since we went over the demo. So the solution workflow can be broken down into 4 components. Detect, where Security Hub identifies these security findings. It integrates with CloudWatch events rule, and then it invokes our playbook, which is essentially Lambda function and systems manager automation documents. And then these playbooks remediates the security findings and logs the details in CloudWatch logs. In the demo, we saw the solution working in one account, but it does support multi-account setup. So if you have member accounts in your organization, they can send their security findings to the primary account security hub. And then the Lambda assumes cross-account role to remediate these findings in your member accounts. And the solution has been developed using AWS CDK. I'll talk a bit more about CDK in the upcoming slides. So let's talk about some of the design decisions that we had to take during the solution development. The first one was designing the playbook, and we chose service catalog for our playbooks because service catalog seemed like a natural fit. It allows you to store all the product information, all the deployable artifacts, and there are some added capabilities that service catalog gives you. So you can implement validations, you can implement security constraints. Let's say if you want to restrict the playbooks to certain users, you can do that in service catalog. Or let's say you want to delegate a particular user as the admin to manage all the playbooks, you can do that in service catalog. Service catalog also fits in our vision where we want to allow third-party providers or vendors to bring in their playbook to remediate findings. So currently the solution, as you saw, has remediation actions in response to findings from CIS benchmark, but there are several other security benchmarks, and third-party providers might want to bring in remediation actions or playbook in response to these benchmarks. And service catalog gives us that extensibility. The second design decision, we incorporated Amazon SNS in the architecture. It's not getting used by the solution itself, but oftentimes we have seen that customers have some sort of trouble ticketing system in place. So let's say there is a particular remediation, it failed, you want to be alerted about that, or you want trouble ticket to be created in response to that failed remediation. So Amazon SNS can integrate with your existing trouble ticketing system. And the third design decision that we took was we developed the entire solution using AWS CDK. If you're not familiar with AWS CDK, it allows you to develop infrastructure as code in your preferred language. So be it Python, JavaScript, or TypeScript, you can bring in those languages and develop infrastructure as code. It also allows us to keep the solution modular and extensible, and we have designed the feature set of the solution in form of CDK classes or constructs. And if you want to extend these feature set, let's say you want to bring in your use case and add it as a feature to the solution, you can follow our open source repository, follow the given examples, and add to the solution. So let's recap some of the key features of this solution. We saw how easy it was to remediate the finding from Security Hub console itself. We saw it in the demo. We saw that the solution works in one account, but it does support multi-account setup. So if your account is a part of organization, your member accounts can also use this solution. You can enable automatic remediation in response to the finding. So whenever there is a finding, the solution will take care of remediating it for you without any manual intervention. Currently, the solution supports remediations in response to the CIS benchmark, but we are constantly working to increase the playbooks that we have in the portfolio. And the solution has been developed using AWS CDK. You can take a look at the open source repository and extend the solution. Now let's transition into the second design principle of infrastructure protection, and this solution, centralized WAF and VPC security group management, aligns with that design principle. This solution is built around the service AWS Firewall Manager, and AWS Firewall Manager supports three kinds of policies: WAF, Shield, and VPC security group policies. AWS Firewall Manager integrates with AWS Organization, where you have to delegate one member account as the Firewall Manager admin account. and you might have several other organizational units in your organization. The Firewall Manager admin account takes care of implementing and controlling the security policies across the entire organization. So what firewall essentially gives us, it allows us to configure, manage and audit firewall rules across your entire organization from single place. And you can use the AWS manage rules for WAF and audit checks for security groups. Now let's see the solution in action. So similar to previous solution, it comes with a pretty detailed landing page, diagram and implementation guide, and we can launch the solution from this web page. But I want to show you something in the guide. Let's scroll down to the prerequisite section. And this prerequisite template comes packaged with the solution. If you are a new customer to AWS Firewall Manager service, there are certain prerequisites that need to be fulfilled, and this template helps you to achieve these. So we'll launch the prerequisite template. We'll give it a name. And there are a couple of parameters that it takes. The first one is the account that you want to delegate as the FMS admin. Whenever I say FMS throughout this demo, it means AWS Firewall Manager service. So we'll use the same account in which we are deploying as the FMS admin account. And the second parameter is if you want to enable config or not. I'll talk a bit more about this shortly. Now let's launch it. Once the stack gets created, we can take a look at the resources, and one of the resources that gets created is stack sets. And we can see the two stack sets here. We are using stack sets to enable config across all the member accounts. So you can see stack set for regional resources and stack set for global resource. Let's take a look at one of these. And if I show you the parameters, you can see we are enabling config recorder for only services that are needed by FMS. If you enable config for all resources, it would cost much more. Now let's take a quick look at the logs being generated by the prerequisite template. If you see the logs, you can see the steps being done by the prerequisite template. You can see each of the prerequisite that was validated and installed, and eventually you get the message that all prerequisites were validated and installed. If there is error in any of these steps, that gets reported in the logs as well. Now let's look at the Firewall Manager console. And you can see the admin as the same account that we provided as the parameter. And one more resource that gets created with the stack is Systems Manager Parameter Stores. And we can see the parameters that got created. We see the three parameters: OUs, regions, and tags. And these parameters are essentially going to control the scope of the Firewall Manager policies. So with OU, you can specify which OUs you want to apply the policies to. With regions, you can specify which regions you want to deploy the policies in. And with tags, you can restrict the scope of the policies to certain resources. So let's provide value to these parameters. So we are going to put in the value of the OU that we want to apply the policies to. We can get the OU value from the AWS organization console. You can see this is my AWS organization. I have a couple of OUs and I'm going to use this particular OU as the one to which we want to apply the policies to. So we'll update the value. We'll provide a couple of regions where we want to deploy the policies. And once we have updated these values, the same should have been reflected on the Firewall Manager console. So let's take a look there. We can see the global policy that got created. And if I go into the regions, we can see the regional policies as well. And we see 3 policies getting created. Couple of them are for security group audits and one of them is for WAF resources. So let's take a look at one of them. And we can see the non-compliant accounts. And if I click on the account, we can also see the resource that's getting flagged. And you can also see the details as to why that resource is getting flagged. So here we can see that the security group was being flagged because it has a rule that allows all protocol, and that is in violation with our rules. Currently, these security group audit policies are set up with automatic remediation as disabled, but if you enable them, it can automatically remediate these violations for you. As I mentioned earlier, you should be thinking of implementing security at scale. And looking at the solution from that perspective, you would understand the benefits it brings. You could implement a consistent set of infrastructure protection techniques across your entire organization using just few systems manager parameters as we saw in the demo. Some of the use cases that you could think of, let's say you want to audit hundreds of security groups across your organization to make sure they don't have over permissive rules. Or sometimes we see unused security groups getting left behind in the accounts and you want to clean up all those as they are potential security threats. Or let's say you want to block bad IPs across your web application resources. You could achieve each of these use case with minimal effort using the solution. And if you think of doing them manually across all the accounts, it would take a huge toll on you. And you have to really take a call whether you want to move fast or stay secure. But the solution makes it easy for you to move fast at the same time stay secured. We also saw the level of visibility Firewall Manager service provides you into the security posture across your organization. So we saw in the demo, to interact with the solution, you essentially update 3 systems manager parameters. Whenever you update any of these parameters, the event is getting trapped by CloudWatch events rule, and it invokes Lambda function to implement Firewall Manager security policies across your organization. We saw the 3 policies that are supported: WAF policy, VPC security group audit policies, or advanced shield policies, only if you are already subscribed to Advanced Shield. And eventually, the operation metadata is getting saved in Amazon DynamoDB. Now let's take a look at some of the design decisions that we took during development of this solution. The first one was, as we saw in the demo, AWS Firewall Manager needs certain prerequisites to be fulfilled. These prerequisites are: you need to have all features enabled in your AWS organization, you need to delegate a particular member account as the Firewall Manager admin account, and then you need to enable AWS config across your organization. You can do these prerequisites yourself, but if you go about it that way, it could take significant time and effort. But if you use the solution, prerequisites get fulfilled for you automatically. And we saw in the demo that to fulfill one of the prerequisites, that was around enabling config in your organization, we are using stack sets. So why did we use stack sets? And one of the reasons for using stack sets is it allows easy management of accounts. So your organization can keep changing. You can add accounts or remove accounts, and StackSet picks up those changes. So let's say if you bring in a new account in your AWS organization, StackSet will enable config in that account without any intervention. We also noticed in the demo that we enabled AWS config service recorder for only the services that are needed by AWS Firewall Manager. This helps us to keep the cost of the solution down. The second design decision, just like the previous solution, we have used AWS CDK to develop the feature set of the solution, because CDK, as I mentioned earlier, keeps the design modular and extensible. The third design decision, we support two deployment modes because we wanted to cater both current FMS or the Firewall Manager customers, as well as new customers who are onboarding Firewall Manager service. So if you are a new customer to AWS Firewall Manager, you can follow the workflow that we saw in the demo. You can deploy the prerequisite template, which helps you to fulfill all the prerequisites of the service. But if you're already using the solution, you don't need to go and deploy the prerequisite template. You can start with our primary solution template and straight away get on to implementing and controlling the security policies of Firewall Manager. Now let's recap some of the key features that we saw in this solution. So the solution automates the setup of Firewall Manager service for you. You can use AWS Manage Rules to implement a baseline security posture across your entire organization. It supports WAF, Shield Advanced, and Security Group policies. We support couple different deployment modes, so you can choose the deployment mode that is suitable to you. And the solution has been developed using AWS CDK, and you can download the source code, tweak it, or extend it in any way you deem fit. So we began the session looking at the design principles of the security pillar of detection and infrastructure protection. And sometimes there can be a dilemma of if you want to move fast or if you want to stay secure. But the two solutions that we covered in this session will help you to move fast and stay secure. So my part is done. Now here are some action items for you. So make sure you check out our well-architected tool. Make sure your workload is well-architected. You can deploy the two solutions that we covered in the session. You can deploy them in your account, see how it works, see how it interacts with your environment, and see if it meets your needs. Just like these two solutions, we have a whole curated library of solutions. So you can also take a look at that library, see if there is any other solution that interests you. And then we invite you to come and collaborate with us on our open source repository through GitHub. So you can take a look at our curated library of solutions, and all these solutions come with a pretty detailed architecture diagram, deployment guide, and all of them are one-click deployments, and you can download the source code and take a look at the code and extend it with your unique case. Here are a few references for you. So the first one is the library that I was referring to, and then the two solutions we covered in this session. Thanks for your time. Please do not forget to take the survey.